You're asked to state the domain using an inequality, set notation, and intervoltation. And for any x values excluded from the domain, state whether it's a vertical asymptote or a hole. So in this case here, the first thing that we have to do is we want to actually factor this because we see that there are two quadratics here. So I'm really going to make this into factored form and by taking the factors at the top and the bottom here. So looking for numbers that multiply to -3, that add to +2, which is going to be x plus 3 and x minus 1 because 3 times -1 is -3 and 3 plus a -1 is 2. Now the bottom here, same idea, multiply to 3 but add to -4, and that would be x minus 3 and x minus 1. So now we have our factored form, and the one thing that we see here is that we can actually cancel out the x minus 1 here because x minus 1 divided by x minus 1 is just 1. And we're going to come back to that when we start talking about the holes here. So first of all, let's talk about domain using the different notations. So for our domain here, we have our inequality notation at the top here, our set notation in the middle, and lastly, our interval notation. So with the set notation, it's x can't equal 1 or 3 because of our denominators here. For interval notation, there's actually 3 of them here, same with our inequality because there are 2 possible values of x that it cannot be. So we're excluding those here, 1 and 3, and 1 and 3. So there's our domain and the different notations. Now let's just take a look really quick and see, okay, is this a hole or a vertical asymptote? So because we canceled out in the numerator and the denominator, then we know that when x is equal 1, then it is a hole. And for when x is equal to 3, we see that it is a vertical asymptote. So that is the line that is a vertical asymptote because it cannot be 3 because it makes the denominator 0, but it does not cancel out to make it a hole. So here is our hole and vertical asymptote and our domain at the top here.